Hello, everybody, and welcome back to another visual pattern challenge. Today, we've got peanuts. So here's our visual pattern. Here's step one of the pattern. Here's step two. Here's step three. And your challenge is to predict the number of peanuts in step four. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of peanuts in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. Okay, so what's going on here? We start with just one peanut, and suddenly we're at 6, so this is growing pretty rapidly, and looks like these are arranged in rectangles, so maybe it's a quadratic pattern, although it's maybe hard to tell. I think what I'm going to do is I'm going to go ahead and just look at the numbers first on this one, and we'll see whether this is quadratic or linear or maybe something else. So I'll put the step number in a chart and then the number of peanuts. So in step one, we've got 1. In step two, that's 6. And then in step 3, there's 6, 4, 1, 2, 3, 4, 5. So we've added 5 more. So that's 11. Ah, I see now. So we started with 1. So here's that 1. And then we add 5 more to get 6. Here's that 6. We add 5 more. So it looks like we're going up by 5 every time. And if we take the difference here, 6 minus 1 is 5. 11 minus 6 is 5. So the next step, I should just add 5. So that would be 16 peanuts in step 4. Okay, so that one for me was a little bit easier to look at the numbers first rather than try to sort out what's happening in the image. You might have done it a different way, but that's okay. So step 4, we're predicting 16 peanuts. Since we've done all this work with analyzing the numbers already, writing an equation is not too difficult. This is linear because we have a constant in the differences, so we can use y equals mx plus b, the equation for a line, to model this. And our slope, the m, is going to be this difference between each step, the rate of growth of the pattern. So y equals 5x. Now what the b is, we have to sort out. If we go to step 1 and we try this stem of our equation out, y equals 5 times, and x represents the step number, so we'll plug in 1. That would give us 5 peanuts. 5 times 1 is 5. We've only got 1 peanut. That is 4 too many. So we actually have to subtract 4 peanuts. And our b turns out to be a negative 4. So I think the equation is y equals 5x minus 4, but we should test this with step 2 here. So let's try that. Y equals 5 times step 2, not plus, minus 4. So that'd be 10 minus 4, that'd be 6. Yeah, that's what we've got in step 2. How about step 3? Y equals 5 times 3 minus 4. 15 minus 4 would be 11. Yeah, that's what we've got in step 3. So this equation, y equals 5x minus 4, seems to be working. So let's use that now to get to the number in step 43. We're going to plug 43 in for x now. So y equals 5 times 43 minus 4. So 5 times 43, well, 5 times 40 would be 200, and 5 times 3 is 15. So that's 215 minus 4. So that would be 211 peanuts in step 43. That's a lot of peanuts. Well, how did that go for you? Did you get 16 for step 4? Did you see that this was a linear equation? Let me know. Thanks, everybody.